Alrighty, gang, I'm going to show you how to determine if a process is spontaneous at a constant temperature and pressure. And there's many ways to do that. I got links in the description using phase transitions as an example. But in this video, I'm going to use the fundamental equation of chemical thermodynamics. The change in Gibbs energy G is equal to the change in enthalpy H minus the temperature times the change in entropy. And in this form, we're assuming temperature is constant. And we're also going to assume that the change in enthalpy and the change in entropy are constant. So what that means is these values don't change with temperature. With that assumption, we can say the change in Gibbs energy at whatever temperature we want is approximately equal to the change in enthalpy at equilibrium. So we're going to choose these equilibrium values right here. You could choose any temperature because with our assumption, the change in enthalpy doesn't change based on the temperature. So we're going to use the value for the equilibrium temperature. Now, these do vary based on temperature. We're just assuming they're not. Over small temperature ranges, you can assume that. Now, to solve for this, we can find out what delta S is, and at equilibrium, the change in Gibbs energy is equal to 0. And if we plug that into our equation right here, we get this. We can solve for the change in entropy to give us the change in enthalpy over TEQ. Every time I see TEQ, I think tequila. Anyways, we'll substitute that into this equation right here, and then we'll factor out the change in enthalpy, which gives us an equation for the change in Gibbs energy. If the reaction is spontaneous, then the change in Gibbs energy is negative. Then the total change in entropy is greater than 0. That's the second law of thermodynamics. We could solve for the change in entropy of the universe as negative delta G over T. I could derive this. It's not too bad from the second law. Hope this was helpful. Best of luck on your midterms and final exams, assignments. Thermal's not an easy subject, but the more problems you do, the better you'll get. And I'll see you in the next video. Cheers.